All right, so in this video, we're going to go through sample question 47 from the Society of Actuaries ExamP list of sample questions. A piece of equipment is being insured against early failure. The time from the purchase until failure of the equipment is exponentially distributed with mean of 10 years. The insurance will pay an amount X if the equipment fails during the first year, and will pay 0.5x if failure occurs during the second or third year. If the failure occurs after the first 3 years, no payment will be made. Calculate X such that the expected payment made under this insurance is 1,000. Okay, so this is a basic question on some of the common continuous probability distributions, right? The four continuous distributions you should be familiar with are uniform, exponential, gamma, and normal. Uniform, exponential, and normal occurring much more than gamma. Gamma you'll probably get one question on. So what information does it give us, right? Exponential, and the main parameter we want to know is that the expected value is 10 years. And it wants us to calculate it in X value such that the expected value under this insurance is 1,000. Now, there are a couple of ways to do this. And there's a way that normally requires integrals, right? Calculate an expected value of a continuous involves integration. However, memorizing one extra thing makes this problem a lot easier. I'm going to set up the first way, and then I'm going to show you the way I would prefer to do it. Okay? The first way would be doing it through just the normal way you should do expected values, right? The expected value of the payment needs to somehow be equal to 1,000, and it should be integrated as such. It's going to be, and in general, it's going to be the value of the payment multiplied by the PDF of your probability distribution. Right? The PDF of an exponential is 1 over theta multiplied by e raised to the negative x over theta. In this particular case, theta is 10. Okay? So, we need to go about computing that. So, this should be the integral. Now, the actual payment differs in year 1 to year 2, 3, and then after that. So that's what I set up my integral, 0 to 1 of x multiplied by 1 over 10 e to the negative x over 10 plus the integral from 2 to 3 of 0.5x times 1 over 10 e to the negative x over 10. And I forgot to write the dx's there. It's something I'm going to consistently do, I feel. Right, and then computing this integral. However, there's an easier way to go about doing this, and that is using the CDF, right? I highly recommend, although it's not necessary, most say that if you want to know the CDF, just integrate and you'll have it. This is why it's going to be useful to memorize the CDF of your continuous random variables. The CDF of an exponential is 1 minus e to the negative x over theta. This thing will allow me to not have to use integration for this question at all. Okay? So this 1,000 should now be equal to the payment for 1 year multiplied by the probability that I'm within that 1 year. So that should be 1. That should be just the CDF of being all the way up to 1. 1 minus e to the negative x over theta. Or in this case, 1. 1 over 10. Plus the payment for being in between years 2 and 3. So that's going to be 0.5x multiplied by, now I need to figure out the CDF between years 2 and 3. Now, this should be a concept fairly familiar to you. If I want to be in between years time 2 and 3 and I have the CDF, I'm going to draw just a nice little timeline type chart. That's 1, 2, 3. What I'm going to do is I'm going to calculate the CDF at time 3, calculate the CDF at time 1, and subtract that away. Just cut that off. And now I have the CDF from time 2 to time 3. So that's going to be 1 minus e to the negative 3 over 10 minus 1 minus e to the negative 1 over 10. If I put this into my calculator, I should get something close to the actual answer, just a couple more steps after that. And I don't have to do any of this integration. So I'm going to go about doing that now. So let's see. The first thing, 1 minus e to the negative x over 1. Hang on. 1 minus e to the negative 1 over 10. That's what I meant. And that gets me a long decimal. I'm going to store it in my calculator as x because I'm actually going to need that right there, right? So this is, I'm just going to approximate, even though in my calculator, when I do the calculations, I'm going to use the less approximated numbers. I'm going to say this is 0.095x plus 0.5x multiplied by, I'm going to calculate this. First, I figure out the CDF for 3, which is 0.2591, this long number. And I subtract away the number I stored, which happens to be this thing. Right, and make sure that's, I put in 3 there, yep. And now this is 0.5x multiplied by 0.1640. Right, I'll just leave it like that. I'll multiply that by 0.5, multiplied by 0.5, and now I get 0.95x plus it should be 0.095x plus 0.082x, and then I add these together, right? This is just, you know, basic algebra. And I'm left with 1,000 is equal to 0.177x. I just divide. 1,000 divided by the 0.177 will get me 5,644, and then it's price. So I'm going to round that to 23 is equal to x. So hopefully you can see this is a lot easier than doing a bunch of integrals, right? Which those integrals would require, you know, use substitution, I think, and stuff like that. And you're going to do it 2 separate times. This is much easier. Memorize this because we have an answer that matches one of our answer choices. Okay, so let's go through this question. This question was essentially asking, rather than an expected value, it gave you the expected value and asked you for an x that would cause your equation to get you this expected value. Calculate an expected value of a continuous random variable is simply, right, whatever's in here. This could be g of x, this could be x, this could be whatever it is equal to just integral of g of x multiplied by the probability density function. Now, when calculating an expected value in this case, it was much easier for me to kind of do something very similar to what you do with the discrete distribution, right? I had a payment for a specific time period. I knew the probability of being within that time period, multiply them, plus the other payment, right? I'm kind of summing for all possible values of x. I obviously I would have had a 0 here if I was fully doing it out, but that seemed unnecessary. And then I just calculated down basic algebra and arithmetic. All right. Hopefully this, fully covered and cleared up any confusion you might have had with this question. If there anything else that you'd like to ask, throw it down in the comments. I'll answer it to the best of my abilities. If this video helped you out, hit the like button, subscribe. That totally helps me out. If you want to see more questions worked out like this, the ExamP sample questions, I have a playlist. Check it out for sure. But other than that, good luck.